Very good morning, good evening. In the last video lecture, we were discussing or we are deriving the equation for a minimum least square least square estimate. It's wrong. I think it is minimal least square estimation, and we obtain the result that j minimum is that but sigma n equal to 0 to n minus 1 x square of n minus sigma n equal to 0 to n minus 1 x of n into h of n the whole square divided by sigma n equal to 0 to n minus 1 h square of n. Okay, so the minimum least square error is the original, I can call that is the original energy of the data that is given from the equation, that is sigma n equal to 0 to n minus 1 x square of n. Okay, plus that due to the signal fitting. Okay, so we will continue with the what you call as least square error to the extension to the vector parameter for the least square error. Okay, in this video, along with the geometrical interpretation. I'll write that one. That is extension to vector parameter. So extension to vector parameter. Continuation of the previous one. Extension to vector parameter of dimension what dimension I will take. I will take that extension to vector parameter. I will call that vector parameter as theta. Okay, theta, just like that one, of dimension p cross 1. Call this small p cross 1. Okay, that is straightforward. For the signal, what signal that is given by s is nothing but s of 0, s of 1, etc, 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 s of n minus 1. Okay, n much to be linear, in the unknown parameter Okay, so I will assume we assume that sorry we assume that unknown parameter to be linear in the unknown parameter. Okay, so we assume that s equal to h into theta, s into h into theta, where h is the vector h is a n cross p matrix, where n should be greater than p, that is for full rank of full rank. Clear? So this h is referred to as got, or H we can call it as that is good. H is, or H we can define as observation matrix. H is defined as observation matrix. Okay. So I write that S here in the form matrix form, that is, as you know, S is nothing but S of 0, S of 1, etc., etc., S of n minus 1. That is nothing but H into theta, which is nothing but H01 or H01, etc., 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 H0p. Okay, then H12, etc., 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 H1p, etc., etc., H of n minus 1, etc., 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 H of n, what called as H of n minus p, H of n1, H of, otherwise we can call this np, 1p, 0p, 1p, etc., np, or n minus. So this is nothing but n cross p matrix. So I will take theta as theta 0, theta 1, etc., etc., theta p minus 1. This is nothing but p cross 1 matrix. P cross 1 matrix. Okay. So we can find the LSE. LSE is found by least square estimate is found by assuming, so sorry, least square estimate is found by minimizing minimizing, sorry, minimizing j of theta should be equal to what? X minus h of theta transpose x minus h theta, x minus h theta. Okay, so j of theta already you know, it is nothing but sigma n equal to 0 to n minus 1. I write as x of n minus s of n square, which is nothing but x minus h theta transpose x minus h theta. Okay, so I will multiply with this one, that is x transpose into x minus h theta minus, so h theta transpose, it can be written theta transpose into h transpose. Okay, that is h theta vector h theta transpose can be written as theta transpose h transpose. Okay, so I am taking this Sorry. Sorry. I'll write it as x minus x theta. And just multiply that one, that is, which is equal to x transpose x minus x transpose h theta, clear, minus what, theta transpose h transpose x minus theta transpose h transpose h theta, theta transpose h transpose h theta. Okay, so the third term, I think you have discussed this one, that is somewhere I have explained how you can change this one. Okay, and the third term, what's first, second, third term, okay, is a scalar quantity, that is theta transpose h transpose x is a scalar quantity, and it can be, that can be written as theta transpose h can be written as h theta the transpose x the whole transpose, which is nothing but x transpose into theta. Okay, so the third quantity, write like that, third quantity is a scalar quantity, or third term, that's good, third term is a scalar quantity, third term is a scalar quantity. Okay, that is, that term is nothing but theta transpose h transpose x. Okay, and can be written as what, this I can change, that is h theta transpose x, since it is a scalar quantity I can write like this. Okay, it is nothing but x transpose h theta. Clear? Okay, now what is your J minimum? J minimum is given by sigma n equal to 0 to n minus 1 x of n minus s of n square is nothing but x transpose x, so this term minus x transpose h theta minus, so now this term changes. Okay, so that is what, that is given by x transpose h theta. Okay, write that result, that minus x transpose h theta, x transpose h theta, and the last term is nothing but theta transpose h transpose h theta. Okay, so this changes to x transpose x minus 2 into x transpose h theta. So sorry, this will be plus. Okay, minus and minus, it will be plus. Clear? A small mistake I made. Okay, so plus theta h transpose h theta. Clear? So now we have to minimize this one. In order to minimize this one, we will normally take the partial differentiation of j of theta with respect to theta. So that is nothing but dou of j theta by theta, dou of j theta by theta by dou theta equal to 0 gives what? You have one identity is there, that is dou by dou theta of b transpose theta will be equal to b. I think that I have derived in the while taking the previous classes. Just verify that one. Okay, that derivation also, how it is getting also, I have derived it. So I use that identity. I will just take that using the identity. Already derived. What? Dou by dou theta of B transpose into theta equal to B, and dou by dou theta of some problem. Using the identity derived, that is dou by dou theta of P transpose, theta is nothing but B, and LSE is not working. Okay. That is clear. Now it is working. Because it is checked. So sorry for that one. So, and dou by dou theta of what? I think that derivation is that dou by dou theta of theta transpose m theta. Here m is nothing but h transpose into h, which is nothing but 2 into m theta. This is the identity that we had derived in the previous case. Okay. So here m is nothing but h transpose into h. So I can write sigma n equal to 0 to n minus 1 x of n minus s of n square will be equal to x transpose P transpose into theta will be B. So what I will do? So it will be 2 x transpose into, that is to be made equal to 0 now. So 2 h transpose h theta V transpose into theta. So it should be with respect to, so the first term will be 0, because what I do discuss is in the first term, that is the first term will be 0, that is x transpose x, that is dou by dou theta of x transpose into x, because there is no theta term. So what happens, that terms will be 0. The next term will be minus 2 x transpose h. Clear? 2 x transpose it is with respect to 2 into x transpose h dou by dou theta of this one, that term will be 2 into x transpose h into x transpose into h. So I can write this as x transpose into h, 2 into x transpose into h, the whole transpose. Okay, 2 into x transpose h transpose. So that will be h transpose into x. Okay, plus the other term will be 2 into m theta, 2 into m is the h transpose into h, H transpose into H into theta, that you have made equal to 0. Clear? 2 H transpose plus, so what happens, this I can make it as equal to minus 2 of X transpose H the whole transpose plus X trans, any mistake there? No, 2 into X transpose H theta, rho by rho theta of P of transpose into theta, so that will be theta. B is nothing but 2 into X transpose H. 1 minute, I am just verifying that there is any mistake or not. Is 2 X transpose H B transpose B theta is nothing but H okay, so that changes to what? 2 H transpose H theta equal to 0. So I can make that it as 2 H transpose H theta is equal to 2 or I will take this like this, H transpose X can be written as H transpose H theta. It's clear? Okay. So I just bringing other one term in the other side. Okay. So this changes to theta cap, which is nothing but H transpose H divided by H transpose into X. Okay. So this is correct. So sorry, it is wrong. It is ulta. Okay, it should be theta cap is nothing but H transpose X divided by H transpose H. So that I can write it as theta cap is nothing but H transpose H inverse H transpose into X. Okay, so this is equation for the values of theta after minimizing. Okay, clear? I will just see whether any mistake is there or not. 2H, the first term will be 0, the second one will be 2, 2x as theta. I'm confused whether any mistake is there. Just I will verify this one. 2H transpose dou J by dou theta spectre 2. Transpose is theta 2 into 2 into square. Okay, I will give 2 into transpose theta. So H transpose X, 2 get cancelled. So theta cap will be H transpose X divided by H transpose X. Okay, so so I can write J minimum as J minimum is nothing but J of theta at theta cap equal to theta becomes equal to theta cap. Clear? So that I can write it as which is nothing but x minus h theta transpose into x minus h theta for theta equal to theta capital. Clear? So what I will do is I will just multiply this one. So what I will take values of theta here. So what I will do, I will write it as this. I can write it as x minus h of theta is nothing but the values of theta is nothing but h transpose h inverse h transpose into x. Okay, that is equation for theta. I include that in that first case. Similarly, the second is nothing but x minus h into h transpose h inverse h transpose into x. Okay, I will call this as vector x. That is good. Clear? So what I will do is I will just take x transpose outside here from here. So what it will be, I can call this as I identity minus h transpose h inverse h transpose. I will take this is in the transpose. I think it is clear. I am taking the x as this vector x. Okay, it is not x bar, it is vector x. So I am taking x outside, so x transpose outside, it will be I transpose minus h into h transpose into h minus h transpose, the whole transpose. That's okay, clear. And other term also I will take just like that. That is, I will take x outside there. This is also x. I will take x outside, so it will be I minus h into h transpose h inverse h transpose into x. So this changes to x transpose x minus that common term I take, that is h into h transpose h inverse h transpose x. Okay, I think it is clear. It's not. Just wait 1 minute, I will just verify. That is, I will take it as identity. So what I will do is in both the case x transpose x, so one is transform, one is the whole transform, other one is nothing but the h transpose h. Somewhere some mistake. Theta, what is the values of theta? Theta is nothing but, so here I have done one mistake. It is not like that. I think theta is nothing but, what is the values of theta? H of s. So here I had done one mistake. So just verify this one. I had done one mistake here. Okay, it is just s inverse. Now it is clear. Okay, here also I have done one mistake. So h inverse h whole inverse. Now it will be h of I. One is nothing but transform, other one is this one, so I can write it as h of h transpose h inverse h of h transpose h inverse H transpose into, it is X is the so I think do one thing. I will just write directly like this. Okay, I will do X as it is, X transpose into I or I vector I transpose identity matrix minus H into H transpose whole inverse, whole inverse H transpose this as X. Now it is clear. Okay, so what I will do again, I will multiply this one inside, they will take into the inside the bracket, so that it becomes X transpose X minus H transpose one minus Y minus, okay. So X transpose X minus, I will take it as X transpose, some mistake I think I had done, no, now it is correct, X transpose H, I have confused here, H of H transpose H inverse H transpose into X. I think now it is clear. Okay, so that changes to, in general that changes to what? So the term, this term, what I am indicating here, that is this term, that is I minus, sorry, this I should not write, I will write only I transpose or I, okay. Anyway, I will write I only, that is good. Okay. Now it is good. I transpose clear. Okay. So the last step, that step result of the fact that I minus H of H transpose H inverse H transpose, that is I minus H of H transpose H inverse H transpose. So this term, so I will write here, this term is an independent matrix, is an independent matrix, okay, or I will call this, it has the property that is A square is nothing but A. Okay, so I can write J minimum is nothing but X transpose X, X transpose H, H transpose inverse H transpose X, that is nothing but X transpose into X minus H theta cap. It's not H theta, right, the vector theta cap, okay. H minus H into vector theta cap. So this is the equation for the minimum least square estimate, okay. J minimum is nothing but X minus X transpose into X minus H of theta cap, okay. So if I take x transpose into this, it will be x minus h into h transpose h inverse h transpose into x. So that is nothing but x minus theta. Theta cap is nothing but, already you know what is theta cap. That is nothing but we have discussed that theta cap is h transpose h inverse h transpose into x. H transpose h inverse h transpose into x is theta. So I can write it as x transpose. If I taking x transpose outside, it will be x. If you want, I will write one more step. Okay, I will just delete this one. I will write one more step. That is good. Don't be confused. I will write here, which is equal to, from this two, I will take x transpose outside. What happens? X minus h transpose h transpose h the whole inverse h transpose into x. So what happens? This term, this term is nothing but theta cap. Okay, just now we have proved. So this becomes x transpose what into x minus sorry, this term is nothing but theta cap. Theta cap is nothing but h transpose h the whole inverse. This term is nothing but theta cap. Okay, don't confuse with them. Theta cap. So it will be h theta cap. Clear? So this is nothing but J minimum. Just make this as box. Okay. Clear. So the minimum least square approach, the formula for that one is that but J minimum, or in general I can call this as minimum least square estimator. So that is given by J minimum is nothing but x transpose x minus h theta cap. Okay. So in weighted form, as we had discussed in the previous examples or those previous derivation, we can have the weighted form also. In weighted form, or I can write this in weighted least square LS. We minimize what? G of theta, which is nothing but x minus h theta transpose W, that is the weighted form, into x minus h theta. I not derive this one, directly we can write, okay, where W is a n cross n positive definite, that is symmetrical, okay, weighting matrix, that is symmetrical weighting matrix. W is a weighting matrix, okay, symmetrical weighting matrix. So the general form of weighted LSE, the general form of weighted LSE least square estimator is theta cap is nothing but h transpose W h whole inverse h transpose W, sorry, x is with respect to, sorry, x. Okay, so this is nothing but the weighted uh, uh, least square estimate. Clear? Just make that also in the box. So in the next section, I will we can come across with the geometrical interpretation of a least square estimate. Okay, so thank you for watching this video. Thanks.